Hey folks, Mr. Ray here again. Continuing on with grade 10 academic math. We are in the quadratic equations unit, and the last lesson we did was solving quadratic equations by factoring. Today we're going to learn the second technique of solving quadratic equations, and that's using the quadratic formula. Okay, now when we used factoring as the technique to solve, it depended, that solution depended on whether or not you could factor it. So for factoring to work, your quadratic equation would have to be factorable, and that's not true most of the time. So the quadratic formula is probably the best way to solve a quadratic equation. It will tell you if there's a solution and what these solutions are. It would also tell you if there's no solutions, and we'll do an example where that works. Okay. Now, if the equation was factorable, it will still work with quadratic formula. So this tool works all the time. It doesn't always give you a solution because sometimes there's not, but like I said, it will let you know if there's not a solution. So here's the quadratic formula. So if you have your equation written in this form here, basically this is a quadratic expression on the left, and if it's equal to 0 in the equation, then you can take the values of a, b, and c. A is the coefficient of x squared, b is the coefficient of the x term, and c is the constant, and you can plug it into this equation here. X equals negative b plus or minus square root of b squared minus 4ac over 2a. And you'll notice that there's a plus or minus there. That basically tells you there's a good chance there's two different answers. Okay, one where you use the plus and another solution when you use the minus. So we'll look at examples like that. Okay, one other term here, normally we don't teach this in grade 10, but it's a good chance to at least introduce it. Something called the discriminant. The discriminant, that's the b squared minus 4ac under the square root. So it will have some practical use. So we will talk about that when the time comes. Okay, so this is just explaining the concept. We have to always rearrange the equation so that it looks like this. So if you had an equation, say it was equal to 9, well, you're not quite ready to use quadratic formula. You have to subtract 9 from both sides. You basically have to clear out one side, make it equal to 0, just like you had to do when we solved by factoring. Okay, so that doesn't change. It has to equal 0, and then you just pull out the values of a, b, c, plug them into here, and you'll get your solution or solutions. Most of the time there will be two solutions as it says here, but there can be one solution and there can also be no solutions. And here's how we're going to use the discriminant. If that little calculation, b squared minus 4ac, if you're doing this when you're getting the solution, and you see that this value is negative, well, you can't take the square root of something that's negative. So at that point, you would just stop, because you can't just fix it. It's not a valid value. So you basically stop right there and say there are no solutions. So that's how quadratic formula tells you there's no solutions. Solving by factoring, you just don't know if there are solutions. There's no way of telling you if there was no solutions. Okay, here's a couple of examples. So we've got 2x squared plus 9x plus 6 equals 0, and you can see that this is arranged in the proper format. You've got your quadratic expression here, and you've got your equals 0. So I would recommend pulling off the values of a, b, and c. Okay, and now we're actually going to use the quadratic formula. So I'm not going to rewrite it. It's right up here. So I'm going to make my long division bar here, and I'm going to have negative b. So I go back and look at, so b is 9, so negative b would be negative 9. Then I have my plus or minus, and then a big square root, and then b squared, so that's 9 squared minus 4 times AC. A is 2, just put it in brackets, and C is 6. Now make sure your square root, the top part of it, the radical sign, goes all the way across to the end here. And then on the bottom we have 2a, which is 2 times 2. And now we just start simplifying this. Okay, so try not to do too much on each step. That's where mistakes are made. I'm going to figure out the bottom part for sure. That's going to be 4 on the bottom. And then I'm going to do each of these two parts. I'm not going to come up with a final answer under the radical, but 9 squared, so I got plus or minus square root. 9 squared is 81. Now, what highly recommend this technique, because you're multiplying 3 numbers and you've got a negative sign or a minus sign in front. So let's figure out the sign first. So you just count up the number of negative signs or subtraction signs, and we've got 1, and that's it. So one negative sign means it's going to be negative, and then we just multiply the 3 numbers. We don't need to consider the sign anymore because we already know what it is. 4 times 2 times 6, that's 8 times 6 is 48. So now the next line, I'm just going to do the subtraction under the radical. So 81 minus 48, that's square root of 33 over 4. So square root of 33, as you know, does not have a nice answer. In fact, the square root of 33 is a decimal that never ends, so we have to actually round it. This would be the exact value, but usually we want to round. And in this question, it actually says where necessary, round to the nearest hundredth, and that's what we're going to do all the time. So nearest hundredth means 2 decimal places. So on my next line up here, I'm actually going to okay, so I've got my negative 9 plus or minus, and square root of 33, if we round, that's going to be 5.74. So I'm going to put that here, and that's still over 4. So this is where we consider the plus minus sign, because the first answer will be negative 9 plus 5.74 over 4. Second answer will be negative 9 minus 5.74 over 4. So this is where we actually split this off into 2 separate answers. First one is x equals negative 9, so we'll use the plus 1 first, 5.74 over 4. Second one is negative 9 minus 5.74 over 4. And again, we're going to use this on the calculator. Round again to the nearest hundredth, 2 decimal places. So in this branch, we get x is equal to negative 0.82, and on this branch we get negative 3.69. So both answers are negative. And you know, anytime you get something that's not a perfect square number under here, you're going to have a decimal place for sure. Okay. So these are the 2 answers. Put some boxes around them so we can see what we actually accomplished. Okay, and in this case we have two answers, and in most cases we're going to have 2 answers. So let's try another example. This time we've got solve this equation, and remember the verb solve in math always means we're trying to find the value of the variable that makes the equation true. So we're basically finding the value of x in each case. Okay. So now we've got this equation, but you notice now the one side, we don't have a 0 there, so we actually have to fix that. So we're going to rearrange the equation by adding 9 to both sides. All right, and so it's still the same relation, the quadratic relation. It would be the same graph, but now we've got the 0 on that side, so we can actually strip off our values of a, b, and c. A is 4, b is -12, c is 9. And at this point, you don't even have to look at the original equation or the one we just rearranged. You can just go straight to quadratic formula with those values. Okay, so now we've got x equals, so it's -b, so negative. Now be careful here, -12 is actually +12. Okay, then plus or minus b squared. So when I do the b squared, you notice when I did the b squared up here, I didn't put brackets around because it was a positive number. But if it's negative, you should put brackets because it's -12 times -12, so -12 squared. I see lots of students that will not put the brackets, and then they'll do 12 squared, 144, and put -144, which would be wrong. So be careful with that. Then it's -4 times AC. So A is 4, 4 times 4 times C, which is 9. Okay, and over 2A, so this time A is 4. Okay, so let's simplify this. 12 plus or minus. Okay, so -12 squared, like I said before, anytime you square a number, it's going to be positive. So in this case, it's 144. And now to evaluate this part, one minus sign or one negative sign, so that leaves overall sign of negative. 4 times 4 is 16, times 9 is 144 over 8. And you see when we do the subtraction now, it actually cancels out. We get a square root of 0 over 8. Okay, so when we evaluate square root of 0, obviously that's just 0. So 12 plus 0 or 12 minus 0, that's the same thing. So basically in this case, there's only going to be one answer, and that's just x equals 12 over 8. So that's going to be, I could reduce that to 3/2. Now this is a fraction that we could easily convert to a decimal because it's exactly the same. We could say it's 1.5. Okay, and there's your answer. So in this case, and this is fairly rare, when you get a 0 under the square root, remember we called this the discriminant. If the discriminant was equal to 0, we actually only have one answer, one solution. So there's another value of the discriminant. If the discriminant is 0, you have one answer. If it's negative, you have no answers. And when it's positive, which is most of the time, like this example, when this value here is positive, you actually have two answers because it's going to be plus or minus a number. So 2 branches, 2 answers. Okay, so there's a good introduction into using quadratic formula. Let's apply it and come up with some other things around it. Okay, so in this case we've got, let's see here, use the quadratic formula to sketch a graph. And I don't think we're going to have room to sketch the graph on this, unfortunately. I didn't leave enough room, but it's basically, we're going to get all the information here. We're going to get the x-intercepts, the vertex, and the axis of symmetry. And once we've got that, it's pretty straightforward to graph when you have the x-intercepts and the vertex. So, so here's just the basic quadratic equation for all points on the graph. So what we want to do is, when we want to find the x-intercepts, we're going to get that first. What we do for the x-intercepts is we set y equal to 0, and that's going to be true of all x-intercepts. The y-coordinate of all x-intercepts is 0. So I go back to my formula here, and I see, oh, it's 0 equals negative 5x squared plus 8x minus 3. Okay, and now I've got a quadratic equation. I want to solve for the value of x. That would give me a y value of 0, which just another way, more mathematical way of saying, let's find the x-intercepts. So I'm going to go straight to quadratic formula. I'm going to pull up my values of a, which is -5, b is 8, c is -3. And again, I'm just going to plug those values into the quadratic formula. So x equals, so negative b, so -8 plus or minus b squared, so b is 8, so just 8 squared, minus 4 times a, -5 times c is -3. Make your radical sign extend across, and then that's over 2a, so that's 2 times -5. Okay, so let's simplify this. So we've got -8 plus or minus, and then the top we've got 8 squared, which is 64. And now, look how many negative signs we've got now. We've got 1, 2, 3. So 3 negatives in a row, or multiplying 3 negative numbers, always gives you a negative number. So we put our subtraction sign there, and then we just do 4 times 5, which is 20. 20 times 3 is 60. And that's over -10. Okay, let's go. We've got x equals -8 plus or minus square root of 4 over -10. And we could simplify this pretty quick. So square root of 4 is actually, 4 is a perfect square, so when we take the square root, we just get 2. So we've got -8 plus or minus 2 over -10. Okay, and at this point I'm going to do my 2 branches. So the first branch, I'm going to use the plus sign there. So x equals -8 plus 2 over -10. So that's going to be -6 over -10. And -6 over -10, that's positive. And I can change that into 0.6. So there's my first answer, because that anything over 10, it's easy to put into a decimal. And then the other branch would be x equals -8 minus 2 over -10. So that's just -10 over -10. So that's x equals 1. So I've got my 2 x-intercepts. So let's bring that up here. I'll just state the fact. X-intercepts are 0.6 and 1. Okay, we also want the axis of symmetry, which we can get very quickly from the x-intercepts. We just find the average of the two, so add them together. So axis of symmetry, it's going to be the equation x equals, don't forget that part, it's an equation, not a number. X equals 0.6 plus 1 divided by 2, that's just getting the average. So that's 1.6 over 2, which is 0.8. So it's x equals 0.8 is the axis of symmetry. But this also helps us with our next part. We want to find the vertex. So the vertex, we already know the x-coordinate. The x-coordinate is 0.8. Okay. So the y-coordinate, what we do, and we've done this previously, we just take the original equation that we were given and we plug in x equals 0.8 to get the y-coordinate. So if we go back here, it's -5 times x, which is given here, 0.8 squared, plus 8 times x again, 0.8 minus 3. Okay, so -5. 0.8 squared is 0.64. 8 times 0.8, that's 0.64. And then we have our minus 3. Okay, so we've got multiply -5 times 0.64. That's going to be -3.2. And if I actually combine these two right here, I'm going to get this is 6.4, not 0.64. I can actually subtract 3 from 6.4, get 3.4. So the y value is 0.2. So that's important. That's the x, that's the y coordinate. There's the x that we already knew. So the vertex is 0.8, 0.2. Okay, so we've got the vertex, the x-intercepts, and the axis of symmetry. It shouldn't be a problem sketching this. You've got those 3 points, but because these are decimal points, it's not. I'm not going to try to squeeze a graph in here, but you could see you could quite easily come up with a sketch. You'd have to stretch out your scale a bit so that you can see where 0.2 and 0.8 are, and that's how you do that. Okay. The next question. Parabola has the equation y equals x minus 2 squared plus 3. Hopefully we know this is vertex form. So it's going to give you the vertex very easily. So first part says state the coordinates of the vertex. And we basically get that from h comma k. So h was 2, not -2. K was 3. Vertex is the 0.23. Equation of the axis of symmetry. If you know the vertex, this is very easy because it's just whatever the h value was. So it's x equals h or x equals 2. The other thing was the direction of opening. So how do we get that? We get that from the a value. So in this case, a is +1. And since it's positive, we know since a equals 1, that means it opens up. Positive value of a means it opens up. Negative value means it opens down. Okay. Using the information from just what we know here, determine the x-intercepts. And then it says verify using quadratic formula. So at first glance, it's kind of confusing. How can we possibly get the x-intercepts just from this? So maybe there's a trick to it. So the clue here is to draw a sketch. So I'm gonna do a little mini sketch. It doesn't have to be a real accurate graph. We know the vertex is 2, 3, which is, x equals 2 is there, y equals 3 is there. So there's the vertex approximately. Okay, and the other thing we know, it opens up. So if I just do a sketch of a parabola opening up, I get a sketch like that. And that tells you quite a bit. It tells you that, well, the vertex is above the x-axis and it opens up. So the parabola will actually never touch the x-axis, which means it will have no x-intercepts. So we'll say no x-intercepts. Okay, and then it says verify using quadratic formula. So again, well, we go back to our equation here, and well, that's not in the right form to use the quadratic formula. Quadratic formula you need in standard form, so no brackets. Can't be factored form or vertex. But here's where we can convert. Vertex form into standard form by just expanding it out. So I'm going to do this fairly quickly. If I square that, I get x squared minus 4x plus 4, and then I have my plus 3 there. So all I have to do is combine the two constants. So it's x squared minus 4x plus 7. So this is the equivalent parabola as we would have with the original equation, but now it's in standard form. We've got a equals 1, b equals -4, c equals 7. So now we'll go back and actually use quadratic formula and see what it shows. Okay, we've never seen this before. We're trying to show that we don't have any x-intercepts. So what does quadratic formula do? Okay, so if I plug those values in, I get x equals -b, so that's -4, which is +4, plus or minus, and I get b squared, -4 squared, minus 4 times a, 1, times c, 7, over 2 times 1. Let's keep going. So now I've got 4 plus or minus, so the -4 squared, that's going to be 16, and then I subtract, count up the number of negative signs, so that's right, it's just subtracting, and 4 times 1 is 4, 4 times 7 is 28, over 2, and you can see we have a bit of a surprise here. We have a negative number in under the radical, so this tells you as soon as you get to that, like I said at the beginning, you get a negative number under there, you just stop and you say no solutions. And since there's no solutions and we're trying to find the x-intercepts, no solutions means no x-intercepts. Okay, and I mean, sketch the parabola, we kind of already did that. I'll just point an arrow up here. I think we kind of had to sketch it before we could come to this conclusion that there's no x-intercepts, but that's the way it looks when you try to find a solution that doesn't exist. An equation like this, a parabola like that where you're trying to find x-intercepts. This is how quadratic formula tells you there's no answer. You get a negative number under the square root sign. Okay, so that's it for quadratic formula as a way of solving a quadratic equation. I've got some questions here for you to work on. Now, you may be saying to yourself, well, how? You've just told me that this quadratic formula works all the time, and it tells you if there's no solutions, one solution, two solutions. So why not just use this instead of solving by factoring? And the bottom line is we just want to be able to see that you know how to use both methods. So I may ask one or two questions on the test. Use solve by factoring for this. But you can use any method you want unless I don't directly tell you which method to use. Another situation where it may be a big advantage to use factoring would be if the equation was already given to you in factored form on the right side and you had a 0 on the left side, or vice versa, and there's no point in expanding and then using quadratic formula, whereas if it's already factored, given to you factored, it's so easy just to solve each factor set to 0. So that is important to know, that you could do solve by factoring in that case instead of going the long way, changing to standard and then using quadratic formula. Okay, so that's it for today. Hope you guys have a good day, and the last part of this unit will be solving quadratic word problems, so that will be our next lesson. All right, talk to you later.